Okay. So, in the last segment we talked primarily about what factors affect compatibility, and we saw there is a whole range of factors, right. So, one has to have a proper understanding of these factors before a combination of cement and superplasticizers is used in the field. It is not always very easy to do that, right, because we know that halfway through the project your cement source may change. Does that mean you completely alter your mix design? Now, very often when any source change happens, either in the cement or even the same source of cement, sometimes you get different quality material. Let me give you an example. Let us say you are doing a project in Chennai, right, and you are getting cement from any company that does not have a integrated cement plant close by. So, they have what are called grinding units. Okay. So, many cement companies set up grinding units in several locations. So, what do they do there? They get clinker from their cement plants, they get the gypsum and they get any other additives like fly ash or limestone, whatever it may be, and do the final grinding alone at these plants, and then they package and sell the cement from these grinding units. That is because it is easier to transport smaller amounts of clinker than to transport the full amount of cement from the integrated plants, right. So, now at these grinding units it is quite likely that the cement company, the same cement company, may be getting clinker from different integrated cement plants. So, for instance, there are several grinding units in the northern part of Tamil Nadu where they get clinker either from the Ariyalur belt, which is about 250 kilometers south of here, or from the Tadipatri belt, which is in Andhra, right. So, the clinker obviously depends on the characteristics of the limestone that is available in these two locations. It turns out that when you make cement with the clinker obtained from Tadipatri or from Ariyalur, it actually ends up giving you a very different characteristic. The cement ultimately has to meet the specs, right. It has to meet, let us say if it is a 53 grit cement, it has to have the required setting time, required strength, all of those things are fine, but the same brand of cement can behave quite differently when you use admixtures because of all the problems that we talked about previously. And in one such case, this indeed was a problem. We saw that the cement used had, or the primary source of the problem was the change in the cement clinker for the cement that was supplied to a particular project. But what happens on a construction site is that if something is not meeting the requirement, the first person to get blamed is the admixture manufacturer. Why is that? Because that is something foreign, that does not need to be there in the concrete. Cement is obviously important for the concrete, but why are they putting this admixture? It is something different, right. Some problem has happened, so it may be because of the admixture. Because of this, the admixture companies, they always have service people who run around between job sites. If there is a problem like this, they run back quickly to their R&D and get minor tweaks in the formulation done until their admixture actually matches the demand of a particular job site. So, the admixture formulations, they keep on changing. As a result, the same product may have 10 different types of formulations, right. For instance, if a product is, let us say one of the products that is commonly used is Rio Build, it is an SNF admixture from Master Builders, Rio Build 1120, right. In one job site it may have the 1120A, in other job site it may be 1120W. It is essentially the same compound, but it has been minorly changed so that it meets the demands of a particular job site. Now, in this situation, in this project that I am talking about, they tried all kinds of things, but nothing worked. So, ultimately when we looked at the overall formulation, we saw that there could have been some changes in the cement characteristics that led to this problem. And indeed, when they went back, they saw that the soluble sulphate part in the cements was changing significantly based on the clinkers that were available in different locations. Okay. So, again, cement companies are not always keen to accept that the problem lies with them, but in some instances they have to see very closely about what is happening. Okay. So, again now just to give you one more example, it is not only all of these factors, there are other things also. For instance, there was a project where we were looking at designing concrete which had very low water content, about 130 kilograms per cubic meter, very low water content. Of course, a PCE superplasticizer was used. Now, when you have a very low water content, I have already talked about the fact that you need to have an extremely good mixing process. In this site, they were not at all prepared. They came with a tilting drum mixer, that RM 500 or whatever, the one they can move around on the site, no? The tilting drum type mixer. So, that mixer which could mix about 0.5 cubic meter, in the first 4 or 5 batches of mixing, it could never achieve the level of workability that was required. But by the 6th or the 7th batch, they had worked out how long they need to mix to really get the system to be effective. If they had had the same concrete supplied with a pan mixer, which they ultimately did, they found a batching plant that was about 30 minutes away from this job site. They went to that batching plant and had the batching plant supply the concrete which was mixed in a pan mixer. Their workability was maintained consistently. So, here they were on the site with a tilting drum mixer which was absolutely not up to the mark to mix a concrete which had such a low water content of 130. So, your choices of the concreting process, how ready you are on the site to actually apply the concrete, also makes a big difference in the way that you can get your systems to be effective. And this is indeed a problem if you are working with concretes of very special characteristics, self-compacting, high strength, all of those things which we will talk about in the later part of this course. When we deal with special concrete, all of these factors may affect the way that you get the required properties of the concrete. Right. Now, in this part of the chemical admixtures chapter, we will take a look at set controlling agents, accelerators and retarders. Now, accelerators obviously are needed when you want early strength, earlier finishing of slabs, early removal of forms, or if you are doing concreting in the cold weather, where because of the low temperatures you may have difficulty in attaining strength fast enough. So, you want to accelerate the concrete mix because the cement reaction is slowed down at low temperatures. Okay. Can cement reaction keep on going if you keep reducing temperatures? Yeah, at a given point, typically we say that around minus 10 degrees Celsius, the reactions may stop. Okay. So, when you are doing concreting at freezing conditions, it is very important to keep the temperature of the concrete high. Even if the ambient conditions are minus 10, you have to ensure that the water has been heated up sufficiently well to get you the required temperature, right. On the other hand, retarders are used when you want to do hot weather concreting, right. When the temperature outside is 45-50 degrees Celsius, if that heat makes its way into the initial temperatures of the ingredients of the concrete, obviously the concrete temperature is going to shoot up like crazy. Okay, we will talk about mass concrete later, but in general about 100 kilogram of cement produces an equivalent of 12 degrees C rise in temperature. This is just a thumb rule. Okay. It can vary depending upon type of cement, of course. For every 100 kilogram cement you have in your mix, your concrete temperature will go up by about 12 degrees. So, if you start your placement of the concrete at 35 degrees Celsius and let us say you have 400 kilogram of cement in your mix, what is the temperature rise or what is the temperature of the concrete that can be expected? The peak temperature 35 plus 4 into 12, 48, 83 degrees can be the rise in temperature or can be the temperature of the concrete, 83, right. So, same thing in the same job site, you try to lower it to 25 degrees Celsius, you are automatically cutting down the temperature rise by 10 degrees. If you go down to 15, you are further cutting down the temperature of the core. It is beneficial therefore, to place your concrete at low temperatures. This is in case of mass concrete structures where we expect that the size is too large and the concrete will start heating up significantly in the center. For normal beams and columns where size is not so big, we are not that concerned. But nevertheless, if we have to maintain workability, we need to ensure that the concrete does not start setting in this process, and we have sufficient workability throughout the concreting process. For that we need to use retarders. And for long haul applications, in Mumbai every concrete they want 3 hours slump retention, because it is unpredictable how long it will take for you to reach the location, right. So, to keep concrete workable for longer time, you definitely need this. There are actually other instances. For instance, you have to supply concrete on a hill, right, and your nearest batching plant is somewhere far away. So, imagine the time it takes to do the climbing to really get to the job site to really deliver your concrete. In such cases, you definitely need retarders to ensure that the concrete does not start setting while while it is supplied to the job site. Now, in terms of chemistry, if you think about your general chemical reactions, we talk about what are known as catalysts. Catalysts are chemicals that are added into the system that can increase the rate of combination of the reactants to produce the product. Okay. So, that is like an accelerator. Accelerator is like a catalyst in a regular chemical reaction. Retarder acts opposite to that. So, primarily set controllers are either organic or inorganic chemicals that interfere with the hydration process of the cement. Now, superplasticizers did not have a direct interference with the hydration process, right, but they did have an indirect interference. What is that indirect interference? Superplasticizers had an indirect interference. Why? They adsorb on the cement grains, prevent the cement grains from directly reacting with water quickly enough, right. So, there is the more admixture that you add, the more retardation that will happen. So, that is not a direct indication, but indirect indication of an ability to retard. But in the case of these chemicals, we have almost a direct involvement in the way that the reactions actually happen. Okay. So, the rate of dissolution of cement compounds that is necessary for hydration to occur, as we discussed earlier, cement particles, the compounds of cement first lead to a dissolution and reprecipitation to really start forming your hydration products. So, this rate of dissolution is either speeded up or slowed depending upon the chemical that you use. So, an accelerator will speed up the dissolution, a retarder will slow down the dissolution. So, this was work done by cement chemists previously, Forsen. He did a classification of set controlling chemicals into 5 categories. Okay. Now, what is plotted here as the time of initial set is not the actual time, it is basically increase or decrease in the time. What is plotted here is actually the increase or decrease in the time of initial set, not exact time of initial set. Which means that if the curve is going up, that means my initial set is going on increasing as compared to a mixture without any admixture, without any of these chemicals. If it goes up and comes down, that means at small dosages there is increase in setting time or retardation, at high dosages there is reduction in setting time or acceleration. Okay. So, that is how this curve needs to be interpreted. It does not mean that your setting time goes up to a certain point and then starts dropping, it is not like that. So, you can almost think that you can almost remove this part of the curve and think that okay, at one concentration you are leading to retardation, at another concentration you are leading to acceleration. So, what are these types of chemicals? If you take type 1, gypsum, which is typically used as a set controller in cement, you have certain minimum concentration that you need to add to really induce this set control, and then the time of setting increases and then more or less remains constant, it does not really increase too much beyond that. Type 2 is calcium chloride and calcium nitrate, which are well known as accelerators, but interestingly when you look at these accelerators, you see that there is a dosage of these chemicals where the set time is actually increasing, and there is a dosage where you get the acceleration. What does this go to show? This tells you that this chemical has opposite effects at different concentrations. So, you need to be very careful in designing the concrete mix with the right dosage of the chemical. At too low a dosage, you are leading to retardation. At high dosages, you are causing acceleration. So, you need to ensure that you have high enough dosages present of the system. Type 3, again similar effect of increase in set at low dosages and acceleration of the setting at high dosages. But what is the difference here, type 2 and type 3? What is the difference? The impact of the admixture is lesser for type 3 as compared to type 2. Type 2 has the maximum impact, type 3 has less impact. Type 4, what does it tell you? It is a constant retardation. If you keep on adding more and more retardation actually happens. Okay. And type 5, they are not effective at low dosages, but at high dosages it is constant acceleration. There is constantly acceleration of the set. Okay. These are salts of formic acid and triethanolamine, whereas type 4 are basically your major retarders that are typically used. Lignosulfonates, sugar is a very well known retarder. Most truck drivers carry a packet of sugar with them to prevent the concrete from settling inside the plant, inside the truck, right? Because wasting concrete is obviously much more preferable than wasting the truck. If concrete solidifies in the truck, that is a loss of several lakhs of rupees, right? Whereas regular concrete, which is about 5,000 rupees per per cubic meter, it is only about 30,000 rupees that you are losing if the concrete gets wasted. Okay. Now, it is interesting to note that certain types of chemicals behave both as retarders and accelerators. So, we need to understand what the chemistry is. So, as I said, the primary effect on the cement chemistry is during the dissolution process of the cement hydration. Now, again another scientist named Josel, he said that the dissolution is affected by these admixtures if we consider the hydrating Portland cement to be a mixture of cations. All the compounds are calcium based, so there is only one cation, that is calcium, and anions, either silicate or aluminate. Let us not even consider C4AF in the system, because that is hardly reactive, it does not react much at all. Okay. So, you have anions which are silicate or aluminate. So, the following combinations according to Josel can happen. 1, an accelerator should promote the dissolution of both cations and anions. So, it should promote the dissolution of the cation, which is calcium, and it should promote the dissolution of the anion which has the slowest rate of dissolution, that is silicate, right, because aluminates, you know well that they react fast, silicates react slowly. So, the accelerator should affect the silicate. A retarder should be just the opposite, right. Retarder should impede the dissolution of calcium, it should also impede the dissolution of which anion, aluminate or silicate? Aluminate, because it is a faster reacting anion. Okay. Now, it turns out that when you have these monovalent cations in your admixture, sodium and potassium, they will reduce the solubility of calcium, but they will promote the dissolution of silicate and aluminate. Why? You are having an admixture that is rich in monovalent anions, cations, sodium and potassium. They are reducing the solubility of calcium by in chemistry you may have heard about common ion effect. You have more positive ions in your system, it prevents more positive ions from coming into solution, right. It would like to get more negative ions in the solution to maintain some equilibrium. So, at small concentrations it turns out that this reduction in solubility is dominant, but when you have large concentrations of sodium and potassium in the system, the contribution to dissolution of silicates is dominant. That is why we see this kind of a relationship. At small concentration that is retardation, at high concentration there is acceleration. Same goes to show for monovalent anions like chlorides and nitrates. Okay. They reduce the solubility of silicates and aluminates, negatively charged species, okay, but promote the solubility of calcium. It turns out that at small dosages this is dominant, at high dosages this is dominant. So, that means that if you use a chloride based accelerator, you need to add high enough dosage so that the dissolution of calcium becomes the dominant phenomenon. Okay. So, obviously we are using mixtures of ions. So, calcium chloride or potassium carbonate and so on. When you have a low dosage, the dominant effect is the retardation. At high dosages, the dominant effect is the, but calcium chloride is the accelerator that cannot be used in reinforced concrete because chloride will induce corrosion, right. So, we have to look for non-chloride chemicals. Calcium nitrate is an option. Calcium nitrite is also an option because it also acts as a corrosion inhibitor, which we will look at later. Right now, we will stop because we are out of time for today's class.